when the question was simple enough that a one shot could get it, they were both pretty good. The RLHF version, the aligned version, was better. But when it was hard, it actually did worse than the base model because you had restricted it so that it actually wouldn't explore all the options. And so the question the paper asks is RLHF actually making a better model? And the evidence suggests that it's not.
Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights in your model without decreasing accuracy. Peter, we have two topics we wanted to cover today. One of them is Eric Schmidt, former CEO of Google. He's talking about some stuff, and then we wanted to get into this sort of RLHF overfitting discussion that sort of popped up this week in a paper. But first, Eric Schmidt, he was recently at a conference and interviewed, and he's talking about some of the Star Trek stuff that's happening, or that he predicts is going to happen in AI. It's always kind of fun to hear some of the visionaries kind of think where this could go. Now, he's super aggressive, maybe, but kind of explain what you heard that he's saying, and what he's saying is most realistic and most fascinating.
Well, so the interview was quite long. There was quite a bit. The parts that interested me was, well, one, he's investing in a lot of AI companies because he's been pretty upfront about that the last couple of years. He claims to invest in every single AI company. And he also is privy to a lot of the research being done at these startups. So like last summer, he was claiming that China was 10 years behind. And now, then this summer, now he's claiming that China is going to be ahead.
Yeah.
So to me, that was interesting because when he said that last year, I thought like, no, I don't think that's right. Because I saw what was happening in open source, and it was clear to me that open source would catch up very quickly. Now it happened faster than I thought, but they caught up. And then the other interesting bits is like people are using AI to do automated research, which we kind of saw hints of that last year with OpenAI's deep research. And then there are other companies also doing kind of search and deep search using transformers. And that was coming. So that was already in development. So that to me was quite interesting because now, in the past, when you're doing like material sciences, or you're doing biomedical or pharmaceutical stuff, they've been using ML for quite a number of years. And if you go back 5 years, a lot of people use ML to kind of like come up with new formulas or new combinations of things. But one thing that you couldn't do was you couldn't design a protein and then be able to effectively test it or to simulate what it would actually do. Now, with things like AlphaFold, you can actually feed in that thing and then have it actually try to protein fold it and tell you what it might do. And so there's that level. And the other level is like actually having robots to actually make that new thing, new compound, or the new chemistry, test it and validate that it does what you think it might do. And so that's quite interesting. It'll speed things up.
Yeah, he was talking about maybe a scenario where the AI is sort of generating ideas about chemicals, pharmaceuticals, or something, and then the robot is, applying it, testing it, doing whatever, and this is happening 24 hours a day,
Yeah.
and so the lab is just cruising through ideas constantly, right? And you're maybe able to get innovation out of AI at a pace that you probably wouldn't be able to do with humans.
Yeah, it reminds me of Edison's famous quote of someone saying, "Well, someone asked him like, so you failed 10,000 times before you found the right solution to light bulbs." And he's like, "No, I found 10,000 solutions that didn't work."
Yeah, for the application. Yeah.
Right. So this is kind of like the acceleration of that, where back in Edison's day, you had to physically go through and test every single filament combination to find one that would work. But now with robotics, you could actually have an army of robots doing this. And then on one hand, it's nice because you're not putting a human in danger. You're not putting some scientists in danger of mixing some potentially explosive or potentially toxic thing.
Yeah.
And anyone that works in a lab knows that when you mix chemicals, you have to put it into a fume hood, because if you mix it and it's toxic, you breathe in, you could
Yeah.
you'll fall over instantly.
Yeah. No, I remember my grandfather, who was a surgeon, who came up during World War II. He had all these ailments and stuff that he, pinned on the experiments that they used to run on themselves with X-rays and all sorts of things that they just, they had no one else to practice this on. What I did find was interesting is that Eric Schmidt kind of makes this claim. Well, you and I talk about what he said within about 24 hours of us hearing another organization that is essentially doing the same thing in a different space. So again, this acceleration of stuff, not to mention the fact that just last week, Marty McCary of the FDA, the new FDA head, said that they're going to eliminate or reduce animal tests because AI can do most of what they need to do on animals, which I know makes a lot of the people like me who like dogs, it makes us happy, right? If they're not going to be testing on beagles. But let's pivot. Something really interesting now on the RLHF side. So describe again for us what RLHF is, why it matters, and what this paper was that came out this week.
Yeah, so broadly speaking, RLHF, basically the process that everyone uses today is they take the whole internet and then they train it, and that produces the base foundational model. So that's completely open, it's unrestricted, it's not aligned to anything. And then people like OpenAI, Microsoft, so on, they have a separate data set called the reinforcement data set, where there's human feedback. So humans have created this other data set that then aligns, i.e., it restricts the model so that it doesn't do things you don't want it to do. So, for example, it will be like, it doesn't tell you, if you ask it, how do I murder someone? Or how do I hire a hitman? It won't tell you. Or how do I
Yeah.
make a bomb? It won't tell you. If you say, I want to build a nuclear weapon, it won't tell you, because we've done alignment, RLHF, to narrow the model. And so this is the same technique used to build a math specific or physics specific or some subject specific model.
And it's not just censoring, right? It's also making the model more usable so that if the user prompts they use the reinforcement learning with humans to make sure that, like, when people ask a question this way, this is kind of what they mean. So
Right.
it's usability too, right?
It is, yeah. So for example, like if you, let's say the base model takes you 5 questions to figure out how tall the Eiffel Tower is, but you want it to respond immediately,
Hmm.
right? So you create your reinforcement learning data set that helps it to train and refine it so that it gets to that in one shot instead of like 3 shots. Instead of 3 prompts, it's 1 prompt.
And it's not RAG, right? We're not
No, it's not right.
throwing prompt into the prompt window. This is actually the model itself has
Yes,
learned how to respond through human interaction. Human guidance has basically said,
exactly.
this is how you
Yep.
do it. Okay, good.
Yep.
So keep going. So the paper.
So the paper did a research where they compared the base foundational model on one side and then the aligned refined model on the other side. And what they found was when the question was simple enough that a one shot could get it, they were both pretty good. The RLHF version, the aligned version, was better. But when it was hard, it actually did worse than the base model because you had restricted it so that it actually wouldn't explore all the options. And so the question the paper asks is RLHF actually making a better model, and the evidence suggests that it's not.
Okay, so just to dumb it down for people like me, so essentially what everybody has kind of been doing, especially OpenAI with their army of humans to do this, is you take a foundational model that you've trained on the internet, on the world, and you use humans to build it up and make it exactly how you would want it to be, right? So it's either censored, it's aligned to the things you care about, but it's also usable in a way that is unique to your model. And you're saying that as you do that generally, but then as you more specifically try to do RLHF towards maybe a math problem or something, as you build up that capability, you're basically draining the pool in all the other areas, and it's kind of getting dumber as it's getting smarter in this area. And that's kind of what they proved.
So that's what the paper suggests. Yep. That's what the data is pointing towards, is that when you align it, you're really, blocking off huge parts of the network of the model. And once you've done that, those weights are still there, but they just never get used.
Explain give the example that I thought you gave me, which was good, and it was like solving a maze.
Yeah, so let's take, for example, we have a huge maze, and there's 1,000 ways to get from the start to the end. And so let's say we make a reinforcement data set that says, focus on all the correct solutions on the left side of the map. So it gets really good at going left. But let's say now you have a car that wants to go right. Well, then it's never going to find a solution.
It might just totally fail. And what's interesting about that is if you take the human brain and you have the human go spend 4 or 8 years on just math in college, right? And they just spend, it's not like the human can't spell or can't read anymore, right? So this is not how human brains work.
No, it's not. So and this goes back to the old problem with neural networks, which is the catastrophic forgetting problem of, like, once you train a base model and you want it to get really good at one task, and you get a new data set that's just for that one task. If you don't include all the previous data and you train it, it'll forget everything else that it's learned. It'll only do that one new thing that you're telling it to get good at. Okay. And so it catastrophically forgets everything else.
And it's not like it actually forgot. That's still in there. It just can't retrieve it very well, right?
Right. So in this case, once you've refined it and aligned it, you've told it, just ignore these parts of the neural network because they're dangerous, right? They don't produce the things that we want, or they produce things that we don't want because they can cause a lawsuit.
Got it. Well, so what do you think the result of that paper is going to be? Where do you think the research will head now?
I don't know, but I think for me the important thing is that paper, if it's true, it means that RLHF will not lead to AGI.
Well, that's a top.
AGI is it's general, it's not specific.
Yeah.
So if you want a artificial specific intelligence, then RLHF is great. But if you want a general intelligence, then it's not.
That's a great way to describe it. And of course, we have no idea what the actual definition of AGI is, but if we could assume a common definition, it sounds like we're not going to get there, at least with just transformers as the only platform.
Yeah.
Good. Well, it's a good topic, Peter. Thanks. Be sure to follow us on Spotify, and if you have ideas of topics you want us to hit, we will take them. In the meantime, we will take questions, and we will check you next time. Thank you.